For simplicity, we'll integrate self-signed certificates in our CRM app to enable HTTPS. Don't worry, I'll explain how to use production-grade certs in a future course. I'll use the term SSL in this demo because all the commands and code involved use that term. Before we can integrate SSL support into the Flask app, we need to generate some SSL certificates. We can do that with the OpenSSL command, and because these commands can get pretty long, I've written a bash script named makecert.sh. Normally, the OpenSSL command is interactive, but this script passes in the required fields to make it non-interactive. First, I create a directory named SSL, and if the directory already exists, nothing happens. Then, I use the OpenSSL command to request a new certificate. We'll use 2048-bit RSA keys with a validity period of 1 year. The No DES option tells OpenSSL not to encrypt the private key, and I want this to be an X509 certificate. The subject of the certificate will contain basic data about my location, organization, and a common name. This should match the DNS hostname of the web server we are trying to protect. In terms of outputs, we will get a private key and a certificate. The certificate encapsulates the public key plus some client data. Both files are stored in the newly created SSL directory. Let's quickly run the script to generate a new self-signed certificate and private key. Now, we can check the SSL directory for our key and cert files. Okay, that looks correct. Next, let's update our Flask app to use these files, which enables HTTPS on our server. I'll jump to the bottom where the changes exist. I'm defining a two-tuple named CTX, which contains a path to our certificate and key files. Once we have this, all we need to do is specify the SSL context keyword argument when calling app.run, passing in this new tuple. Flask makes it easy to add SSL support in this way. We also need to update our Docker file because these certs need to be part of our Docker image. I'm aware that using self-signed certificates in a public Docker image is generally a bad approach, but let's keep it simple and focus on the integration. All we need to do is add another copy command to copy the SSL directory from our dev box into the container, much like we did with our source code. There are no changes to our Docker Compose file, so let's just rebuild and run the app using Docker Compose up --build. Okay, now our Flask logging says the server is listening for HTTPS requests on port 5000, not just HTTP. Let's test it out in a browser. Given our untrusted self-signed cert, most browsers will warn you that the connection is suspicious. Let's examine the details. From here, let's view the certificate so we can manually inspect it. Here are all the details we specified in our OpenSSL command, and even though our browser doesn't trust it, I feel confident that we are at least talking to the correct server. Let's visit this website anyway by clicking this link. Your operating system may ask you to authorize it by explicitly granting permission, which is fine. Now we are at the CRM app homepage. Notice the lock icon in the browser address bar. This means we are using HTTPS. Let's test account 100 again, which is a valid account we expect to return a balance. And naturally, let's test Nick123, a non-existent account. Okay, it's invalid. Let's head back to the shell to check the logs and see if anything changed. These HTTP post logs look identical to the previous demo, and they should, because once the transport security is removed, the application processes the HTTP requests the same way. Supporting HTTPS on your web app is usually a good idea, and I always encourage developers to experiment with different approaches to enable it.